Welcome. This is a demonstration of my Agentic RAG chatbot. It is built on a decoupled architecture with a React frontend and a FastAPI backend. Now, as you can see, I've already uploaded a document called Operating Systems Unit 3 Notes PDF, and then you can see the status here. It's saying the processing is complete, and then the number of chunks processed are 51, and also the session IDs generated using the UUID module. If I ask it, let's say, what's this PDF about? It gives me an intelligent answer along with the sources where it has picked up that answer from. And also, if I ask another question, describe critical section problem, which is already defined in the PDF. As you can see, it gave me an intelligent answer as well as it has given me the chunks where it has parsed the answer from. Now let's look at what exactly is happening in the backend. Right now, the ingestion agent is parsing into the document into text chunks. Immediately after, the retrieval agent is converting those chunks into numerical vector embeddings, as you can see here, using a highly tuned sentence transformer model from Hugging Face. The response is generated, as you can see, LLM response generator, the final answer. The response is generated by retrieving the most relevant embeddings from a FICE vector store. Why is that the case? For this follow-up, the retrieval agent first uses an LLM to rewrite my wake question into a specific standalone query, and then it performs a sophisticated two-stage re-ranking to find out the absolute best context before generating the final answer. And you can also see that the sources are not just large paragraphs. The coordinator performs a final step to extract the most precise snippets such that they directly support the answer, which is a key feature for versatility. Now let's look at the basic flow of the process. Now the user uploads documents and asks the question. The React UI using API calling sends request to the coordinator agent, and now the coordinator agent orchestrates the other agents. The agents you see here, like the coordinator agent, the ingestion agent, the retrieval agent, the LLM response agent, all of these agents are not just Python classes, they are independent API endpoints. Now, the coordinator orchestrates this entire process by making asynchronous HTTP calls. So the core of our knowledge base is the FICE vector store managed by the retrieval agent. This isn't a traditional database, it's a high performance index of numerical vector embeddings that represent numeric meaning of our document chunks. Now, as you can see, the flow is pretty self-explanatory. The coordinator agent orchestrates other agents, and then it calls upon the ingestion agents, which takes in the which parses the document and then divides it into chunks. And then again, all of these communicate using MCP. So the retrieval agent stores and retrieves chunks, and then the LLM response agent acts and gives a finalized answer. And then whenever there's an error, it falls back to a lower model, and then it generates the output. And then the React UI, it shows the source chunks to the user. As you can see, our project is divided into two equal halves, the backend as well as the front end. Now, the foundation of our project of my project is in the vectorstore.py file. So now to perform semantic search, we first have to convert text into numbers. We do that using a powerful open source model from the Hugging Face sentence transformers library. So this model is brilliant as creating a 384 dimensional vector embedding for each text chunk. Crucially, it outputs normalized vectors, meaning the mathematical length is exactly 1. This is the key. Now, how do we measure a similarity? The goal is to use cosine similarity, but you won't see that function in the code. we're using a clever optimization here. You will see we initialize something called FICE index flat L2. Okay, because our sentence transformer gives us normalized vectors, minimizing the L2 distance is mathematically identical to maximizing cosine similarity. Now, this is a highly optimized standard industry practice that gives us accuracy that we desire. This powerful vector search is the first step into our retrieval agent. After using the FICE database for a fast initial search, we get 10 candidate chunks, as you can see in the code, a highlighted code here. We implement a second most precise stage. We use a cross-encoder model to re-rank those 10 candidates. A cross-encoder is more powerful because it evaluates the query and the chunk together, giving us a more accurate relevant score. Now, finally, all of this is triggered from a React front end. In the main app.tsx, the component, the handle send message function constructs a fetch call to the coordinator API's endpoint. Now, coordinator API, as we discussed, is the orchestrator of all the other agents, sending the session ID as well as the user's query to kick off the entire backend workflow. Also, I would like to discuss this prompt that I gave the LLM. We are using a Grok LLM. You're a helpful AI assistant that answers questions based on the provided document context. For specific questions, you have to find the answers in the provided content and respond directly. Now, this prompt is very, very basic, and it does not have any complexity associated to it whatsoever. This decoupled microservice architecture, combined with advanced RAG techniques like cross-encoder, re-ranking, and an optimized vector search, it creates a system that is not only scalable and maintainable, but also delivers highly accurate and verifiable answers. Thank you.